Hello and welcome. In today's tutorial, you'll learn how to integrate Reallusion characters into Unreal's Advanced Locomotion System, ALS, which is another widely used game control framework aside from GASP. ALS enables characters to blend seamlessly between different animations, supports layered animation, foot IK, and even ragdoll physics. While both GASP and ALS are popular Unreal control systems, today we'll focus on ALS, with GASP to be covered in a separate tutorial. Here are the key differences between these two game control systems. Either launch Character Creator 5 or 4.6 and start with your game character loaded in the scene. Open the Export FBX menu and set the Target Tool preset to Unreal UE4 Skeleton. Then expand the Advanced settings. With this preset, the Epic skeleton is automatically assigned as the UE4 skeleton, which matches the skeleton used by the ALS character. Next, navigate to the Add Reference Pose section, and the option is automatically set as A pose for UE4 skeleton as well. This ensures that your character's bind pose is fully compatible with ALS. For more details on retargeting, be sure to check out our separate tutorial on Unreal Engine retargeting settings. Finally, change the FBX export option to Mesh, enable Delete Hidden Faces, and then export your character. Open the fab and search for Advanced Locomotion System. Add it to your Epic Games launcher, then create a new project. Be sure to select Unreal Engine 5.4. Finally, install the latest Unreal Auto Setup plugin to ensure your character integrates correctly with the project. Open the project and press the play button to enter game mode. Take a moment to move the ALS dummy character around. Notice how you can switch between different layered animations and walk across terrain with foot IK automatically adjusting the feet. But how do we replace this dummy with our own character? Start by creating a folder and importing our character. Select HQ Shader and be sure to disable Use T0 as ref pose as well as import morph target if you don't need facial expressions. Doing so can save a significant amount of time during import. After importing your character, you'll see that both the IK Rig and Retargeter are automatically configured. Open the IK Retargeter and you'll notice that the source and target are both set to your character's IK Rig by default. To retarget animations, you'll need to switch the source to the ALS dummy character. However, this project does not include a pre-configured IK Rig for ALS, so it won't appear in the source drop-down menu. As a result, we need to manually configure the ALS IK Rig. Navigate to the Advanced Locomotion V4 folder, then go to Character Assets, Mannequin Skeleton, Meshes. Here, you'll find the skeletal mesh of the ALS character. Simply right-click on it and select Create IK Rig. Open the IK Rig for the ALS dummy character. First, click Auto Create Retargeting Chains to automatically generate the bone mapping. Check the generated chains and fix any mismatches. For example, the left leg chain may run from the thigh bone all the way to the toe bone. Change its end bone to the foot bone instead. Do the same adjustment for the right leg chain. Now, the leg chains are properly set, but we need to add chains for toes as well. Click Add New Chain and name it Left Toe, and also create the right toe chain. Afterwards, set both the start bone and end bone to ball L in left toe chain, which is the left toe bone. The same goes for the right toe chain. Next, click Auto Create IK, and Unreal will automatically generate 4 IK goals for the character. Check the foot IK goals, as they are incorrectly attached under the toe bones by default. Move them manually to the foot bones instead. Then click Reset to apply the changes. With that done, the ALS IK Rig is now properly configured. Now, open the IK Retargeter again. This time, you can select the ALS IK Rig from the Source drop-down menu. Adjust the target mesh offset for a clearer view. Let's verify compatibility. You'll notice that the skeletons share the same bind pose, thanks to choosing the A pose for UE4 Skeleton option in CC. You can also toggle skeleton visibility to confirm that the main bones align correctly. This works because they all use the UE4 Skeleton, which has 3 spine bones and no extra palm bones in the hands. In the Asset Browser window, you'll find animations from the ALS dummy character. Simply click on any of them to preview the retargeting results. Once satisfied, save the IK retargeter. Next, we need to set up a few blueprints. Let's break the process into 2 steps. Step 1. Configure the animation source. Right-click on your character's skeletal mesh and create an animation blueprint, then open it. We need to manually set up the retargeting source. Drag the result output and search for Retarget Pose from Mesh. In the Details panel, assign the IK Retargeter asset to our IK Retargeter. Then, compile the blueprint. This stores the retargeted animation data within the animation blueprint. Now that the animation setup is complete, we need to replace the ALS dummy character with our own. Navigate to the Advanced Locomotion V4 folder and go to Blueprints, Character Logic. Open the character blueprint for the ALS dummy character. Go to the Viewport tab and you'll see the original mesh. To change the mesh, add a new skeletal mesh under the original one, rename it, and assign it to your character. Your character will now appear in the viewport, but without animation. Assign the animation blueprint we configured earlier to enable the correct animations. Finally, hide the original ALS character by searching for visible and disabling it. Compile the character blueprint, and your character is ready to go. Once you've completed these 2 steps, play and re-enter game mode. Your CC character can now move freely within the project. Notice how the character walks smoothly, adapts to different terrains, and transitions seamlessly between layered animations. This workflow is also fully compatible with ActorCore characters, allowing you to smoothly bring any ActorCore asset into the scene. That wraps up today's tutorial. Be sure to check out our other tutorial on setting up the GASP game control system. See you next time.